Good morning.
Good morning.
All right, so let's see. We missing Ricky today? Who's here?
He's here. He's talking to the aide.
Okay. All right. How about Holbrook? Can we miss any? It looks like we're missing somebody there.
Raylyn and Ina.
All right. You. All right. So, anybody have a joke for me today?
What a riddle do?
Sure, I'd love a riddle.
Okay, so I'll tell it real fast. There's a guy that lives on the 12th floor of a hotel. He goes down for work, and then he comes back up in the evening. However, he cannot go all the way up to the 12th floor unless it's raining or he has someone with him. Why? If it's not raining and there's no one with him, he has to go up to the 10th floor and then walk the stairs.
He's too short to reach the 12 button on the elevator.
Nice.
Then he can use his umbrella to push the button.
Ah, that's very good, Lauren. Have you heard that one before? Or
I haven't, but Ricky kind of gave me the answer.
All right, well, that's awesome. That is awesome. Okay. Well, let's see. Well, that's a good riddle. All right. Well, let's see. Pick up where we were yesterday. So we're on 3-6. And we are, just the back side. Okay. So, all right. Well, let's get to teaching here. All right. Okay, so it says to use a graphing utility to graph the sum or difference of two functions, you enter the functions as y1 and y2 and the sum or difference as y3. Here's the deal. I mean, I actually think that these are probably easier to do by hand. But like I told you, as a student, I was obsessive with being able to check my work. And with a calculator, I know I would want to know how to do this. So I'm not sure if this necessarily is easier, but let's go through it here together. So let's say we want to find the f of g of 2. Okay, f minus g of 2. So we take the f function and we type that in for, here, let's look over here. We don't actually need the graph. So we type y1, the first function in for y1, and then the second function in for y2. And then if we're adding, then for the y3, we do y1 plus y2. If we're subtracting here, we got to make sure we're subtracting in the right order. And so we type in y1 minus y2. All right, now let's see. Let me grab the calculator and let me just show you. You might not know how to get the y1 and y2 up there. Is that your question?
Well, it's mine, so.
Oh, okay. So let me just show you. Basically, you're going to use the variables key. It just says vars, but it means variables. We're going to use that menu. Okay, here we go. Okay, so to get the you go to like the y3, okay, where you're going to type it in. And so to get y1 minus y2, you go to VARS, variables. It's right next to the clear button. So variables, and then you want y variables. So you arrow over to y variables, and then we're in function mode. So then you press enter for function, and then it lists them. So then you y1 plus y2, y2 minus y1, whatever it is you need. Okay? So let's say if I was doing y1 plus y2. So I press enter for y1, and then plus, and then I go back and do it again for y2. So it's variables, y variables, and then function, and then there's the list. Okay? All right, now, so let's go ahead and, so then to plug in the number, let's see. All right, let me just make something up here really quick, because this is important. So x plus x squared. Okay. So then I don't really, so to get the y3, the sum, so there's a couple of ways you can do it. If you graph it, and then what you want to do is trace on the y3, and then you can plug in any number. Okay, so if we go to the y3, let's see, no, okay, I want to trace, and so it tells me up here what line I'm tracing. So y1 I don't want, y2 I don't want, okay, y3, that's the sum. Okay, so now if I type in any value for x, it'll give me the value of the function. Okay, so like if I want y1 plus y2 and then plug in -3. So now I just, on the trace, so I just type in -3, press enter, and so it gives me the value of the function y1 plus y2 when x is -3. Okay? All right, so let's see if you can do that for practice 1E. So type the first function in for y1, the second function in for y2, and the third function will be y1 minus y2, and then plug in -3. Now, if this is all confusing to you, you don't have to know how to do this. Okay? I'm just trying to give you a way to check your work on the calculator. All right, so Lauren, when you've got it.
I got 9.
All right. Oh, I got 5. Oh, you were probably just tracing the y1. Okay, so go back to your calculator. Do you still have them in?
No. Hold on. Okay, I have it.
Okay, so when you press trace, make sure that you're tracing on the y3.
Okay.
Okay? Then type in -3 for x. Or, yeah, -3. And then press enter. Okay, did you get it? No.
So when you go to click trace,
All right, I got it.
Okay, you got it? All right. See, the reason why, if you just plugged in -3 in for the f of x, the y1, you would get 9. So that's what made me think that when you press trace, you have to make sure that you're tracing on the y3. Okay? All right, anyone need me to go through it again? Calculator? Okay. All right, so you type in for your y1, you're typing in the first function. Okay, so x squared. Okay, for the y2, you're typing in the second function, 1 minus x. Okay, so now it's f minus g. So for the third function, it's y1 minus y2. Okay. All right, so then when you press graph, you got to make sure that when you press trace now, well, let's wait and let it graph. Okay, so now when I press trace, see it says y1 up here. So I'm going to arrow down y2, arrow down again y3. So now I'm tracing y3. And so now I type in what I want to plug in, -3, enter, boom. So the answer is 5. Okay. All right, but again, you don't have to know all that. You can just do like we did yesterday. It's easy enough. But I kind of like the check. And when the functions are a little more complicated, you know, if you're doing x cosine x minus sine squared x. Oh, wait, we don't know trig yet. But if you have a complicated function like that, it's a lot easier to plug in like this. Okay? All right. Whoops. Okay, next, composing functions. Okay, the composition of the function f with the function g is, and the book will usually write it as f and then like this O circle thing, g of x. This is how I prefer to write it, where it's the f of the g of x. So in problems that I write, you'll usually see it like this. Okay? So the idea is that for a function composition is that you plug the number into the whatever function is closest to it first. You work that out, and then whatever you get from that, you plug into the next one. Okay? So in the composition of the function f with g, the domain of f of g of x is you use the restrictions of both f and g. So like if you're not allowed to plug in 2 into the f function, you can't plug in 2 into the f of g either. Okay, so the restrictions still apply. All right. So let's say f of x is x squared, g of x is x plus 1. Okay? So to find the f of the g of x, that means here we don't have a number. So we just take this whole function, g of x, and then plug it into the f function. So in place of x, we're going to plug in x plus 1. So it would be x plus 1 squared. Okay? So you put the whole function in for x. All right? Now, let's say I wanted to had a number to plug in. So the f of the g of 3 and the g of f of 3. So let's see if they're the same thing. So if I find I find the g of 3 first. So I plug in 3 into the g function and I get 4. Then I take that result and plug it into the f function and get 16. All right, let's do it the other way. So here I plug 3 into the f function first. 3 squared is 9. Then I take that and plug it into the g function and get 10. So what this means is the order matters, okay? These are not equal. The g of the f of 3 and the f of the g of 3 are not equal. So you've got to make sure you do it in the right order. So you plug into the function nearest the number first, then work that out, and then plug that into the outside function. Okay? All right, so go ahead and try practice 2A. Both of those problems. All right, Jay, what do you have for the f of the g of 2?
15.
15 is correct. Good job. All right, and let's see now. Serena, how about the g of the f of 2?
Ten.
10? 10 is not correct. Okay, so for the g of the f of 2, you plug 2 into the f function first. Okay, so the f of 2 is 2 times 2 plus 1. So that's 5. So then you take 5 and you plug that into the g function. The g function says take 2 times 5 squared minus 1. So 5 squared is 25, times 2 is 50, minus 1 is 49. So the answer is 49. All right, any questions on that?
Can you go through the first one just one more time?
Sure.
Practice 2A.
Okay, so the f of g of 2, you could write it like this. The f of the g of 2. So you plug 2 into the g function first. So that's 2 times 2 squared minus 1. So 2 squared is 4, times 2 is 8, minus 1 is 7. So now you take 7 and plug that into the f function. So that's 2 times 7 plus 1. 14 plus 1 is 15. So the order again matters. You got to make sure you're plugging into the right function first. Okay. All right. Any other questions on that? Okay, so when evaluating the composition f of g at a point x, there are two reasons the value might be undefined. So again, it's zeros in the denominator and negatives underneath the radical. Okay? You always have to look out for those two things. So when you're doing function composition, you have to look out for that. Okay? All right, so let's say we have the f of x is x squared minus 4, and g of x is the square root of x. Okay, so find the formulas and state the domain. So we'll do the first one together, and then I'll have you do the second one on your own. So first we're just gonna find the formula. So without plugging in numbers. So the f of the g of x, okay? All right, so you think this is the same thing as the f of the g of x, or the f of, so the f of, okay, g of x is the square root of x. So now what we're going to do is take the square root of x, what the g function was, and plug that into the f. All right, so the f function is the input squared minus 4. So it's the square root of x squared minus 4. Well, the square root of x is just x minus 4. So that's the answer, the f of the g of x. But see, here's the thing that you have to look out for, is from the beginning, when we plugged into the g function was the square root of x. So see, we couldn't plug in any negatives to begin with. So if we can't plug in any negatives to begin with, that means that my composition isn't going to have any negatives. So the domain is going to be all numbers greater than or equal to 0. Because if I can't plug in any numbers to begin with, I'm not going to be able to plug in any to the composition. Okay? All right. So let's see if you can do the second one. So find the formula, g of f, and then see if you can figure out what the domain would be.
Mr. Strong,
Yes.
so when you have the f of g, that means that you would put g in for x on the f of x equation, right?
That's correct. The g function. That's right.
G function. Okay.
So the g of x is the square root of x. So now in place of x into the f function, you're going to plug in the square root of x. So instead of x minus 4, it's the square root of x squared minus 4.
Okay, thank you.
Okay. All right, so Lauren, when you have g of f.
I set it up, but I'm not sure what the domain is.
Oh, okay. Well, the domain is tricky. So just tell me what the g of f is.
Okay, it's the square root of x squared minus 4.
Okay, so all underneath there. So
Yeah.
the square root of x squared minus 4. So any questions on that? Okay, so for this, what I would just say is as long as you know that the stuff underneath the radical has to be greater than or equal to 0. Okay? So if you just know that x squared minus 4, x squared minus 4 has to be greater than or equal to 0, then that's okay. Okay? And so notice that they have different domains. Okay? So it just kind of depends on the order that you're working in. Okay, so any questions on either of that? Either of those. All right, well, so that's function composition. All right? Okay, so now what we're going to do is what's called function decomposition. Okay? Now, let's see, where's the blank though? Okay. That's not what I want. Oh, I guess it is. Oh, did I skip that one? No? No, I don't want that. Mm-hmm. Okay. Okay, there we go. So to decompose a composite function, you look for the steps to evaluate. All right, so what I mean by that is that you look for how you would break it down. Okay, so let's see, this is... Okay. Now, there's more than one way to do it, okay? So let's say that we had this function right here, okay? And I wanted to break it down into the functions that make that up. The way that I think about it is I think, okay, if I was plugging in a number, if I was evaluating, if I plugged in a number here for x, what would I do first? I would subtract 3. So the first function is going to be x minus 3. So whatever the input is, I subtract 3. Then the second function, the second operation I would do would be to take the square root. So I'm calling that the second function. And so then this right here, what I started with, is actually the b of the a of x. So first I subtract 3, then I take the square root. Okay? All right, so let's say I had this. Well, what would be the first step here? If I plugged in a number and I was going to evaluate, what would I do first? What operation?
Multiply.
Multiply. So I'm going to say my a of x is 2x. All right? And then I would do what?
Add 5.
Add 5. So my second function is adding 5. And then my third function would be to take that and cube it. And so that's my third function. So then in this case, it's the a of x, well, it's the c of the b of the a of x. So there's actually 3 functions that are combined together. Now, you might combine a couple of these. So you could break it down into 2 functions instead of 3. I like to do it step by step like that. Okay? All right, so go ahead and try practice 3A. Okay, and the blank is there's more than one way to decompose a composite function. And go ahead and when you finish 3A, if you feel like you're up to doing 3B, then go ahead and do that as well. All right, Cottrell, what do you have for practice 3A?
I got for a of x is x squared.
Yep,
Then b of x is x plus 4.
that's it. Good job. Okay. All right. So there's more than one way to decompose a composite function. So sometimes you might, especially if there's like 3 or more steps, some people will combine them. Okay, so while you're working on this one, let me tell you a story. So there was this guy that loved music, and he went to Paris because he heard that Wolfgang Amadeus Mozart was buried in Paris. And so he wanted to, go to his grave. And anyway, and he goes there to the cemetery, and he hears something weird. And it's a little scary, a little weird, scary, a little spooky. So anyway, he goes over to the caretaker and he says, what's that weird sound I hear? It's almost like Mozart's music being played backwards. And the caretaker says, yeah, that's exactly what it is. Mozart is decomposing. No? All right. Okay. All right.
No, that was really good.
All right. Okay, so let's see. Who did we land on? Taylor. So what do you have for this one? What's the first function?
Can I get help on this one?
Sure. So think about if you were plugging in, let's say you're plugging in 7 for x. Okay? What what operation would you do if you were trying to evaluate this? If you're plugging in a number for x, what would you do first?
Would you subtract 7 from 8?
Yes. So the first function then, how I would write it is the first function is 8 minus x. Okay? All right, then let's say you worked that out, then what would be your next operation? So first you would subtract from 8, and then what?
The cube root.
Yes, you do the cube root second. So it's important that you do it in that order. So the next function would be the cube root, and then finally the last operation would be to do what?
Divide by 5.
Divide by 5. Now notice here I'm using, because this problem had F, G, and H instead of A, B, and C, it really doesn't matter what you call the functions. What matters is that you have to have them in this order. So 8 minus x first, cube root of x second, x divided by 5 third. Because that's the order that you would do the functions. Okay? All right, any other questions on this one? On anything on 3.6? All right, so now just as a reminder, we are not doing the quiz on 3.6 tomorrow. What we're doing is 3.2, 3.3, and 3.4. Okay, so study up on those, practice those. All right. Let's see, that was 3.6. So now we're going to go on to 3.7. Maybe. Okay, so 3.7 is about inverse functions. All right, and this is gonna, we're gonna talk about inverse functions now, but later in chapter 5, in a couple of weeks, this is gonna be super important. But since we're talking about functions, they put it in this chapter. And this is the last section in chapter 3. So if we'll probably finish this on Thursday, and so probably in a couple of weeks though is when we'll have the test. All right. So inverses of relations, inverse functions, and the horizontal line test, finding inverse function formulas, and then 4 ways to determine if you have an inverse. That's going to be what we're working on here. All right, so first of all, inverses of relations. If the point AB lies on the graph of F, then the point BA lies on the graph of F inverse. So notice this notation for the inverse. It's F minus 1. I personally hate that notation because I think of it as like a negative exponent, but it's not an exponent. It just means an inverse, okay? And vice versa. The graph of F inverse is a reflection of the graph of F in the line y equals x. All right, so if we have points, so here's my function, 1, 2, 7, 5, 4, negative 12. All right, then the inverse function, you just switch the order of all the x's and the y's. So the inverse function would be 2, 1, 7, 5, negative 12, 4. Okay? All right, so on your practice problem, it says to, well, actually, before you graph do the practice problem, what I want you to do is draw this line, y equals x. Okay? Draw that line on the graph. Because when you draw a function and its inverse, it should be reflective through that line. It should be symmetric through y equals x. Okay? So what I mean by that is if you graph points on one side of the line, the inverse will have points on the other side of the line. Okay? Or if you graph a curve on one side of the line, its inverse will be a curve on the other side. So it's reflective symmetry. Okay? All right, so go ahead and do practice 1. All right, so I'll just have you check your graphs. Okay. So the original function, so 4, negative 1, so they're in green. All right, then the reflection, the inverse functions are in red. So notice the symmetry, that a function and its inverse are reflective, so they're symmetric through y equals x. Okay? Now, when you have the points, the domain is just the x values, and the range is just the y values. But notice when you switch the points, the domain of the inverse is the same thing as the range of the original function. And the range of the inverse is the same as the domain of the original function. So let me kind of show you visually. Let's go back to. Okay, so like if I have the f of, for whatever the function, if the f of 3 is 10, then the f inverse of 10 takes you back to 3. Okay? Or like if this is the domain, then the function, if the function takes your input, the 10 to 20, then the inverse function takes you back to 10. Okay?
So Jeff, you don't switch positive and negatives though, right? You just change their location.
You just change the location. Okay? All right, so Avery, do you know what this is?
Can you say that
Do you
again?
know? Do you know what this is right here?
Yeah.
A house?
It's a home on the range. Okay. All right, let's go back. Oh, wait. So for a function f and its inverse, let's see, is this the next blank? The domain of f is equal to the range of f inverse. And the range of f would be equal to the what? So what's the range of f?
Domain of f inverse.
Would be the domain of f inverse. Okay? And see, the reason why I hate the notation for the inverse is, see, we're kind of programmed to think that for like polynomials, you use the elevator rule. So this would be like 1 over x squared, right? But see, f inverse, that doesn't mean 1 over f. Because, see, this is a function. It's a function. So but I hate that because I always want to think that. And I hate that some students might get that confused. So I don't love the inverse notation, but it is what it is. Okay? When I write my book, I'm coming up with my own notation for inverse. I think I'm going to do like F and then like capital I for inverse. But that's in my book. It doesn't exist yet. Math the strong way. Okay, I guess we did that already. All right, so let's see. All right, so now what I want you to do, okay, so let's start with that line y equals x again. So draw that. So y equals x. All right. Now what I want you to do is draw y equals x squared. Don't be grabbing for that calculator. You know what that looks like. Okay. So now using y equals x as that mirror, that line of symmetry, see if you can draw the inverse. Okay, the reflection through the line. Now this is where like you artistic types have a huge advantage because sometimes it's kind of hard for me to actually draw like reflections through a line. I don't know why, but okay, so you should have something like this on your paper. So y equals x, and then y equals x squared, that's the green parabola, and then its inverse is the red. So something like that, okay? It doesn't have to be perfect. Okay, mine's certainly not. All right, any questions on that? Okay, so y equals x squared, that's a function. Is what we just drew the inverse? So that red would that be a function? Well, so let's see, okay? It says...
It doesn't pass the vertical line test.
That is right. So if since the red doesn't pass the vertical line test, it's not a function. So before you even graph it, to tell whether a function has an inverse that's also a function, from its graph, you use the horizontal line test. So the horizontal line test on the original function will tell you if its inverse is also a function. Okay? So you do the vertical line test to see if your graph is a function. The horizontal line test to see if its inverse is a function. Okay? So here's where my Catholic students have an advantage, because the Pope does the vertical line test and the horizontal line test. Okay? So you just do them in that order. Okay? So like here, is this, would this be a function? Yes, it passes a vertical line test, but it fails a horizontal line test because a horizontal line would hit it more than once. So this would not have an inverse function, nor would this. Horizontal line would hit it 3 times. Okay, so does the graph of the function at the right have an inverse? All right, let's Tara. What do you think?
I don't understand.
Does it pass the horizontal line test? Did a horizontal line hit that graph more than once?
Yes.
Yeah, it would hit it more than once. So that means the answer is no, it does not have an inverse. Well, its inverse is not a function. Does not have an inverse function. Okay? So for the explanation, you could just say fails HLT. Fails the horizontal line test. Okay, so we're going to finish up with this. A function is one-to-one means let's see, there's an easier way to put it. It has an inverse. So if I say, is the function one-to-one, that means that the original is a function and its inverse is a function. It has an inverse. Okay? All right, so that is a good place to stop right there. Okay, so we'll pick it up from there on Wednesday. So we will finish on Thursday so tomorrow you'll have quizzes on 3.2, 3.3, 3.4. Then Thursday we're going to finish 3.7, chapter 3, and then we'll start in on chapter 4. So be looking for the guided notes for chapter 4. I'll be sending those the student success organizers before class on Thursday. Okay? All right. Any questions, comments, concerns?
Actually, Mr. Strong, I do have just one question. So when you say if its inverse is not a function, then it doesn't have an inverse? Is that like?
Right. When we say does it have an inverse, we mean does it have an inverse function.
Okay. So that's all we care about. We don't care.
That's all we care about.
Okay. Got it. Thanks.
All right. Thanks. You guys have a great one.